Welcome everyone to the first tutorial. So today we're going to go over a couple of tools you can use to do data science and big data analysis, and then we're going to hopefully by the end of the tutorial actually start a little bit of analysis, learn some summary statistics, and be able to do some statistical analysis using software and be able to make visualizations of data. So there are three major options that you can use, and we're going to focus the tools in this course on open source tools. So open source means that the actual source code of the tool is published online and it's free to download, it's free for you to edit, you can contribute. So all the licenses are completely free, and the reason that we're focusing on these tools is because at least two of the tools are basically the standards that are used in industry. So those two tools are the programming language called Python. And with Python, there's a lot of libraries that could be used for data analysis. And together, you can call that the data science stack of Python. So you install a bunch of libraries, and it gives you all the statistical visualization, machine learning, data mining tools you need. The other tool that you can use is R. R is a statistical programming language, and it has very powerful stats packages. And if any of you guys have used MATLAB, R has a similar kind of idea where everything is stored as a vector, where MATLAB everything's stored as a matrix. It's a similar kind of idea. And the last tool is Weka. So Weka is an open source graphical user interface. So there's no real coding. There is coding if you want to be advanced, but it's a basic graphical interface that you can click buttons and get started. So we're going to start with that. I can show you what Weka is and kind of how to use it. The second one is Python, so I'll get started today as well, showing you how to use Python and using a tool called Jupyter, where you can actually program in your browser, and you can start typing Python code and stuff using Jupyter. And then this course is not going to focus on R. I will talk about it here briefly. Professor Golab did say that a couple of you in the class does know R, and if you do know R, then you can use it. We might use it later on in the course, but I think it might be too much to learn all of it. So the focus, at least for these tutorials, will be on Python. So Python is a general purpose programming language. It's very popular, and it's very popular because it's very easy to pick up. And as you'll see, if you want to print something, you just do print and then you write it. If you want to do addition, if you want to use any of the libraries, it's very easy to pick up, and there are a lot of tutorials and online guides for it. And yeah, so why don't we get started with using Weka. So Weka, I use it personally to do quick visualizations. It is developed by the University of Weka, and you can download it on this link. So you can go ahead and for Windows, you can download it and install it. So I personally use Linux, so the procedure to open it will be different. But when you download it, if you go to the download site, you can download it'll download an exe, and then you can install the exe, and it'll create a little icon, and you can double click it. In Linux, we can open it by going to Weka and running this. So sorry, this is for Windows. You download the exe and you can install it. For Linux, you just open it and it will open up. So it'll allow you to do various tools. The main tool that you could be using for this course is the Explore. So if you click the Explore button, Weka will open up here, and it has different tabs for different parts of the analysis. So one's pre-process, and eventually you can cluster, you can visualize, and really you can use this tool for almost all of the concepts that you'll learn in class. The disadvantage with using Weka is that it only works on your computer, so you can't run it on a server. So when you're dealing with larger sets of data, sometimes you use a more powerful computer called a server, and Weka doesn't really run very well on a server. So I use it for just quick data analysis, to look at my data and to make hypotheses with it, to explore the data. But you can do almost anything with it. And the link that I posted on the course website has the tutorials. So if you go to the book, there is a book, and he has the slides, and you can read the slides. In addition, there is the data mining course. So there is a full course that you can actually get started with. And if you go here you can actually watch YouTube videos that have him using all of the different techniques. So for this reason, I'm not going to focus them on the tutorial. If you want to use Weka, you can actually just go here and watch his videos and actually start learning it that way. I'm going to focus on Python, which is next. So in Weka, just quickly before I move on to Python, I can show you how to do just basic visualization, and then I can leave it to you to use Weka throughout the term and to read the tutorials while I focus on Python. So you could reproduce the analysis I'm doing in Python in anything you want. You can do it in R, you can do it in Weka, you can even do some of the analysis in Excel. Even though those options aren't recommended, there's still options for you if you don't want to code. So with Weka, if you go to the open file, you can open up a CSV. So for those of you who have used Excel, Excel saves data in a tabular form. So you have columns and rows. What a CSV is a comma separated value file. So it's the same file that you would see in Excel, except for each number will be, or each value will be separated by commas. So it's a smaller way to represent the data, and it's how a lot of these applications open. So if we go to, I'm just going to open up some sample data set. So for example, this is the iris data set, which we're going to learn later on and we're going to play with. So you just double click it, it opens up the CSV. If you wanted to see what the CSV look like, it's almost the same as an Excel file. So if we go to data sets, we can just open it up. Sorry, this is the Excel file. You can actually just open up the CSV and it will open up in, I use LibreOffice, which is just a clone of Excel, but this is what a CSV looks like. So it has all the values and it has, similar to how you would see it in Excel. And you can open that same file format up in different programs. And the difference between a CSV and a full Excel file is Excel files have sheets at the bottom. A CSV you can think of as just one sheet for Excel, if that makes sense. So a lot of, when you download data off the internet, the most popular file format is a CSV, because you can open it in Excel, you can open it in Python, you can open it in Weka, you can open it in anything. So you can do basic data analysis, and the great part about Weka is it makes these visualizations automatically. So you can automatically get some of the statistical measures that you learned in class. So the mean, the standard deviation. The other thing you can see down here is a histogram, and the color in this case is the class for iris. So a little bit about the iris data set. An iris is a type of flower. There are 3 different families of irises, and if we click iris, you can read the different types. So there's iris setosa, versicolor, and virginica. I'm probably pronouncing them incorrectly. But this is a data set that a statistician just published years ago that kind of shows clustering, and we're going to learn classification with this data set. I just wanted to show you what the data set looked like now, just to demonstrate Weka. So the flower has a sepal, so that's like the sepal length of the flower, and then there's also the petal length and the widths. So a statistician actually went out and measured each one. So you can see the histogram for each of them. So down here you can see the histogram, and in blue you can see it's usually in the order which it's in. So these are each of the 3 irises that I talked about, and these are the distributions for each of them. So that's a really great way to just start looking at your data. You can look at the mean, the standard deviation, the max, and the min for each. Another great tab that I like using on Weka is the Visualize tab. So over here, if we go back to the Excel file, you can see there's the sepal length, the width. What it does is it plots each of them versus each other. And it's a little bit hard to see on the screen here, but you can see, for example, this is the petal width versus the sepal length, and you can see the petal width versus the petal length. You can also double click each of the plots and it will open a larger plot, and the colors you can see down here. Blue is the iris setosa, the versicolor, and the virginica. So you can actually see that there's a linear relationship in this case between the petal length and the petal width. So the real power in plotting multivariate data, where you have multiple features or inputs, is you can see relationships with each other, and sometimes you can verify assumptions. So later on when we go into modeling, if you want to run linear regression and the data is linear, then you can fit a linear line. If not, then you have to figure out a different way. So the real power of using the data visualization is actually answering questions about what your data looks like and validating your assumptions before you start actually building models, and that's very important. So this is Weka. In Weka, you can also pre-process and you can choose filters. So here you can like, for example, subsample. You can change the order. You can do some filterize. You can normalize the data, and you can do a lot of things in Weka. So there's not almost always, but there will be equivalents for what there is in Python and R in Weka. So if you wanted to not code, you can just use this tool and follow the video tutorials online here, and you can do almost all of the project depending on your data set. So next we're going to move on to using Python, and the tool that I use for Python is something called Jupyter Notebook, and I'll show you what that is. But first I want to ask, have any of you guys used Python before? No? You have? Okay, perfect. And some of you have coded. Just by show of hands, who's coded again? Coded before? And what have you guys coded in? C? Okay. So the programming paradigm for Python is almost the same as C. I too started off like in engineering as well, so I started off with C and C++. Ever since I started doing data analysis, I learned Python. I actually learned it in like half an hour. It's actually very, very simple and easy. The for loops it's also object oriented. Printing's a lot easier. The library's a lot easier. You don't have to worry about like int main or any of like the crazy coding. You can actually just get started. So let's just get started. What I'm gonna do is I'm gonna first show you how to install it. I'm gonna show you the links to installing it. You have a couple of options. So my guess is most of you use Windows. Is that correct? Okay. So I use Linux, but the simplest way to install Python and most of the tools that you'll need is using this thing called the Anaconda distribution. You can just search Anaconda Python, and I also have the link. And it's created by Continuum. So each system is different, but you can install Python this way. So they have a tool that you can use, and when you're using Python, I highly recommend to use Python 2.7, not Python 3. Just don't use Python 3, and the reason behind that is a lot of the libraries that you'll be using, especially if you're going to use Python in the future, is only has support for 2.7 for now and for like a very long time. So to save your headache later, just trust me and install 2.7. It's kind of like how there's C and there's C++. Python 2.7 is a previous version than Python 3, but it has a lot of the legacy libraries. So I highly recommend you use it. For Windows, you could just install the graphical installer, and this will take you through a wizard that will install most of the packages that you need. So the disadvantage with Python is, Python's a very general programming language, but people built libraries on top of Python. So if you want to use statistics, you have to install the stats model library. If you want to make charts like, let's say like MATLAB, you have to install the matplotlib library. So I'll show you how to install the libraries as well. And for those of you who are dealing with larger sets of data, and by larger than the RAM of your computer, so my personal laptop has only 4 gigs of RAM. So if I'm dealing with a data set that's larger than 1 or 2 gigs, it's going to slow down my computer. So what I like to use is Linux, and there's a little learning curve to start to use Linux. So what I recommend is maybe install it using Windows and get used to it there. But what we'll learn in the next tutorial, and when I start actually using the server, is the same tools that we're using for Python in our web browser that's running on our local computer in Jupyter Notebook is the same that you can run on a server. So you have the same advantages of just being able to do everything locally, but yet have the power and the computational power of having a server. So I'll leave this as an activity for you guys to do at home to install Anaconda. Just go through the wizard here. And if you have questions, I can help you next tutorial, or you can email me. So I'm going to open up Jupyter Notebook on my computer, and we can get started. So so I'm just going to go to the tutorials. So for me to open it in in Linux, I just write Jupyter Notebook. On Windows, you're going to have, again, another icon that will show up. And you'll double click it and it will open up your web browser. So it'll run at a thing called localhost on your computer and a port number. And what this is doing is it's running a little server on your computer, and then it has a file browser, and you actually have interactions. So in the folder that you open it in, it's going to show you all the files that are present. And in this case, I have some IPython notebooks. So normally you can go to to new, and then create a new notebook, Python 2, and then you can actually just start writing in Python right now. So if you want to do simple things like 1 + 1, you can type it in the cell, and if you hold Control and hit Enter, it will display the result. If you want to print something, Python's a very simple language to use. You can just write print, and then in quotations, hello, and it will print hello right off the bat. No including libraries, like none of that. Python's actually very easy. Doing for loops is also so doing things in Python is a little bit different than you would do it in C or another language. In C, you would do from for I in between these values, and then increment every time. In Python, you can actually for loop within data structures. So I think we'll go over the basics of Python later. And I'm going to start with the notebook that I prepared. And we'll learn the implementations of some of the syntax during the tutorials, like as I do data analysis. I did post some links on the course website for how to get started in Python. So I recommend you just read through those like basic tutorials. And a good book actually it's free online. It's called Python the Hard Way. So if you actually go to here, you can actually just go to the exercises. And it kind of sets you up with doing it. So I'm not going to go over it here because I think you can read the guides online and be able to do things. What I've learned is that Python also has a ton of libraries. So if you want to be able to do something, like for example, you want to be able to make a box plot, which we'll learn how to do later, you can actually just Google search it, and reading how to do it based off of like Google results, so let's say like Stack Overflow or some websites, is sometimes more helpful than trying to read the whole documentation, because there are so many different libraries, so many different packages, that getting advice off the internet is actually helpful. So while it might not always be the right answer, it usually points you to the right documentation, and actually saved me a lot of time just Google searching it. So why don't we start with basic data analysis using Python. And I can show you Rstudio very quickly for those who want to use it and get a sense for what it is. Rstudio it's like a MATLAB-like IDE or integrated development environment, a GUI that you can use that also runs on a server. And my computer, when I start opening things, my computer slows down. Sorry. So this is R. R is also pretty powerful. It's great for statistics and stuff. So in here you can write code kind of like MATLAB. Down here you can write command line code, like whatever you want to do. Actually, there's some warnings. And then you can view your environment. You can view data variables in here. So if you can like view you can view your data frames and stuff in here once this opens. And you can do a lot in R. So this is Rstudio. We're not going to focus on R just yet. But it is an option as well for those of you who have used R. Rstudio is another tool you can use, and you can install Rstudio from their website. They have like a Windows installer that you can use, and they also have like Linux, Mac, and all of the tools that I show you are cross-platform. So no matter what you're using, Linux, Mac, or Windows, you can do it. You can download Rstudio, and they actually have a desktop version that you can use as well if you're using Windows. So if we go back to Python, why don't we start with learning what we did in class. So let's learn by example. So I'm just going to show you how to open up a CSV file in Python, how to do basic plots, and then how to use summary statistics. And hopefully while I do these tutorials, I'm going to kind of not only show you how to use Python, but I'm going to like show interesting data sets and things that I think are interesting and things that you should know. So hopefully you get a lot away from these tutorials. So we're going to start off with exploratory data analysis. And as Professor Golab said, before you start doing before you run any models, you should first understand your data. And what that means is there are two things. One is using statistical measures, so that's using your mean, your standard deviation, understand the distributions. And the second thing that I'm going to really promote here, and something that I highly recommend you do, is make visualizations. Visualize your data first, because by visualizing and looking at it, you can actually get insights that you otherwise wouldn't get. So I have a couple of CSVs that you can follow, that we can download. But I also, in this document, which I will share, so I published this online as well. Here's some Python links that you can just kind of get started, basic like calculator and how to use functions and everything else. You can just go through some of these tutorials, and it'll help you out. But also just looking at sample code and understanding what's going on, and using IPython notebooks, so just running a line of code and seeing what it does will help you learn Python, I think, a lot faster than spending like 5 hours and like doing a tutorial or reading a book or whatever. Because I like to learn by doing. Everyone learns differently. You can also find tutorials that will go step by step on how to do it. So here are some CSVs that I have, and I added the links to it. So like just like any other file, you can save them. When you open up, the key thing to know with IPython Notebook is when you open up IPython Notebook, it opens up in a it opens up a root directory folder. So when I run it, it runs in this folder on my computer, which is like slash. I usually store everything in a code folder, so it's code, and then let's say you can do MSCI 723, and then I'll open it there. You can save the data sets in that folder itself. Or what I like to do is I like to make my own data sets folder and put all the data sets in that folder, and I make it one level above. So what that means is if we go back to the Explorer, if this is where, so I opened up IPython Notebook in this tutorials folder right here. Up one level, I created a folder called datasets, and inside of the datasets folder, I keep my datasets, and that's what the dot in IPython Notebook you'll see. So what this means is, what this means is go up a level, and then it's in datasets. The other great thing about IPython Notebook is it's actually a notebook, so you can take notes and write in it. So here you can see that I actually just wrote plain text and links and stuff like that, and down here there's code. And the way to switch is if you go to cell. So when you open up IPython Notebook, you can go to cell. You can also go to insert. You can insert cells above and below, and you can also change the cell type to be in Markdown. And when it's in Markdown, you can just write anything you want. So you can do a title. So if you use a hash, you can write a title, and you can write like this is text. And then if you hold Control Enter, it'll actually just write it as text. If you want to do a subtitle, you can do. And I really like annotating my code when I write it, because like weeks later, days later, I come back, I have like no idea what I did. So I like writing out what I'm doing step by step. And the great thing about IPython Notebook is you can publish them online. So I'm going to publish these online. You guys can download it. You guys can install it. So when you're doing group work in general, whether it's for this course or doing data science in general, you can create reproducible research, which is great. It means anybody can download your IPython Notebook and run the same code that you did and get the same results. So it's a lot easier than sharing files and binaries and like all of this stuff. You can just share the IPython Notebook and the CSV file. Yes?
Just a quick question.
Yes.
When we try to download it, once we run the exe file,
yes,
we get like a prompt box, but we don't get this interface.
Okay, so I'll do a Windows specific tutorial where you can like open it up and get IPython Notebook running. I haven't used Windows in a while. But what I'm also going to show you guys in the next tutorial is how to run it on a server that you can connect to the server. And actually I can show that later in the tutorial. So in the same way that I'm using Linux, you can actually become a member, for example, of this computer science club here and get access to their servers and run IPython Notebook on their servers and then connect on your computer with that same interface. So why don't we get back to IPython Notebook. And also you can worry about installing it later at home, and if you have problems you can email me. The other thing you can do is get the user interface tour. So if you go to help, a user interface tour, it will walk you through all the different various parts of IPython Notebook. And for this reason, I'm not going to go over it in any more detail. You can just go to help, go through the user interface tour, and you can learn how to use IPython Notebook. So this is the CSV files that we're going to use in this course, and this is basic code. So to import libraries, you use the import function, and all the as is. So I do import matplotlib.pyplot as plt. The reason that I use plt np pd, that's a common way. It's because when you use a library function, you have to use the library name in front of the function, and that's very long to write. Like I don't want to write numpy or pandas every time. So I just put, so if I'm using a pandas read, I put the PD in front of the read CSV. So I go over what each of these three libraries are down here. But matplotlib is a plotting library similar to like MATLAB's plotting library. NumPy is a great implementation of an array in Python, and it's actually has a lot of optimization code that runs in the background based off of C and C++. And it's pretty sophisticated, and there are a lot of libraries you can do with NumPy. So you can take a mean of an array, you can take the standard deviation, and it has all of these functions. So I left the links to each of these libraries here. So this is matplotlib. As you will see, there's a gallery. So if you want to learn how to do different types of plots, the best way is just look at the gallery. If you want to do, for example, a histogram, and just look at the code that they had to generate that histogram, and learn from the code instead of trying to read a book on it. So that's what I like doing for matplotlib. For NumPy, there's like a getting started guide, and there's a tutorial, and you could read through the basics here, like how to create arrays, and various other aspects. So the difference between NumPy and pandas is NumPy is an array, meaning that each column can only have one type of variable. Sorry, the whole array can only have one type of variable. In Excel, each column and each cell can have different types. That's what pandas is. It's built on top of NumPy and allows you to have a data frame. And I'll show you what a data frame is. So here, what we do is we do pandas read CSV. So I downloaded this file, the CSV file, into my datasets folder, and I read it, and I call it whatever I want. For example, this dataset that we're using is the sorry, I can't pronounce this, but the Anscom's quartet. It's 4 sets of data that will show us a really interesting result. So I'm not going to spoil what the result is, but they're just, let's say, 4 sets of data, X and Y. So the read.csv will open it. We can view it. So by doing print, we can look at what the data looks like. So X and Y. You can also view the full. So in Python, if you want to index a list or a data frame or anything, you index it. You start at the element you want to start and the element that you want to end at. So this is going to print the first 5 elements. If I wanted to print the first 10 elements, I can go 0 to 10. Sorry. And the problem why I got that error was because I didn't run the previous code. So whenever you start a new notebook again, you can go to restart, clear all outputs, and restart. So what happened was I had my results already there, so I thought that it was running. So every time you open it, you can clear the results, and you can go to each cell and click Control Enter. The other thing you can do is you can do cell and then run all below, and it will run everything and it'll run all your code. So now I loaded each of the data sets. You can view the data sets by doing print. In IPython Notebook as well, you can actually just take the object itself and then hit Control Enter, and it will plot the full data set. And if you open up the CSV in Excel, it will look almost identical. So here we have a data set. It has X and Y. Each of the data sets look the exact same. They are 10 sets of data points that have, very interestingly, the same statistical measures. So to describe the data, there's a function that you can use in pandas called describe. And here, for clarity, I'm only going to put the first 3 descriptive statistics. So all I did was I just did my object, my data frame, dot describe, and it gave me the description down here. So if you just want to see an output on your own, on its own, you can go to insert, let's say, cell above. There are also hotkeys that you can learn. If you go to keyboard shortcuts, you can actually read the hotkeys. So for this, you can do, you can paste it here. And if we just want to see the full output of the describe, you can do print, and then you can remove the end, and you can see all the summary statistics. So the count, the mean, standard deviation, min, max, and the quartiles. That's one statistical measure that you can use. The other thing that you can do is you can index your data frame by the name, which we'll learn in the next section over here. So you can do .x or .y, and it will plot just the x and just the y. And in this case, if you notice, that's the label up here, x, and there's y. So you can also, another way to index it is you can do it like this, and it'll index the x column or the y column. I like using the dot because it's a lot shorter, and that's kind of your. You can also you can use, for example, if you want to take the mean, you can Google search how to take the mean of a list or something, and the result that will come up will say, hey, you can use the numpy library. So, or you can use the statistics library. There's so many different libraries you can do the same thing in. So in this example, if you do numpy.mean, it will output the mean of it. Using the numpy library will already have optimized code to be able to do that. So the shortcut to delete a cell is escape and then dd, or you could have done, or you can do, I think it's edit delete cell. So these are each of the data sets, and the really strange part about this is if we look at the description here, actually I'll full screen it so it's more visible. If we look at the description here, you can see the count is just the number of elements. Here's the mean and the standard deviation. If you notice, the mean and the standard deviation for each of these data sets are like almost identical, and that's crazy, right? And what we're going to see is that even though the mean and the standard deviation, which are your standard summary statistics that you always look at, they can be really deceptive. They can all be the same, but the data sets can be completely different. And that's why it's very, very important that we visualize the data. I also made an Excel sheet that you can download I don't think I put the link here to. I'll put the link to it later. But there's an Excel sheet that you can download, and you can look at all of the you can actually look at all of the you can actually look at all the summary statistics here as well. Yeah. So this is the Excel sheet for the exact same data set. So I included the data set here. You can look at the mean, the variance, and the standard deviation are actually all the same. Even the covariance and the correlation between them are identical as well, and it's crazy. So you can view this data set later and play with it, but the point is that using just the summary statistics that you learn is not enough to understand your data, which is why it's very important to visualize it, and I'll show you why. These are the visualizations of the 4 data sets. So this one just has a lot of noise. Down here we can see this one is non-linear, and this one is linear, but it has an outlier, and this one has all of the same value, and it has just one outlier. Yet, when you look at the summary statistics up here, the summary statistics are, the summary statistics here are exactly the same. So that's why it's very important that you make these visualizations and you learn how to visualize the data before you build any models. And even when you build the models, visualize the results, because you should have an intuitive understanding of your data before you start analyzing it. And this is very important for your projects. So what I recommend is when you start getting your data sets for your projects, visualize and understand the data that you're dealing with first before you decide on something, because the quality of the data is very important. There's this computer science and information saying, which is garbage in, garbage out. If you have garbage data, big data analysis and like data science and stuff is not going to make it any better. It's not magical. it's just going to give you garbage out as well because your results are bad. So if you're missing data, if data is improperly collected, you're going to get poor results, and you're going to struggle with the projects and everything. So it's really important that you learn to visualize, and that's why I wanted to right away not go into details of Python, not go into anything, but really show that data visualization is very, very important. And we can learn the details of how to do the analysis later. But hopefully from this, just looking at this data set, how deceptive these summary statistics could be. This is a box plot. So here, I didn't know how to use a box plot in matplotlib. So when I was doing this tutorial, I literally just Google searched it, how to do a box plot, came out, and I found a tutorial on the site, on the gallery, and it's as simple as just doing PLT. So that's the matplotlib library, box plot. Sorry for the scatter plots, I didn't show the code. The scatter plots is just PLT scatter, your X, your Y, and you can set your color to be whatever you want. You can actually go to, so that's blue. You can also go to the matplotlib library that I talked about. Which I don't think I have open, but you can just go to the matplotlib, and what I usually do is just look at the sample code in the gallery and see how they did what I want to do, and then take the example code. And I think that's a lot faster and better than trying to like read all of the documentation, because like I'll probably fall asleep if I were to do that. So yeah, that's how you do a box plot, box and whisker. If you go to the documentation, which I also provided a link here, it can show you different examples of box plots. You can add the outliers. You can change the symbols. You can make them horizontal. You can do a lot of things. Like the libraries are very powerful. But one thing that I would like to really emphasize, and I do have a document that kind of shows this, is the point of exploratory data analysis is not making like fancy infographics that will show up on a magazine. The point of it is to come up with quick visualizations for you to understand your data. It should be simple and intuitive. You should look at the plot and within a couple seconds be able to understand what's going on. And when you share that figure, other people will understand it as well. So the next library we're going to talk about is the Seaborn library. And installing it, when you use Anaconda, you can just use conda install Seaborn, and it will install it. If you're using Python, you can just do pip install, and it's built on top of matplotlib, but it's very, very powerful. And the reason, and when I say powerful, what I mean is it has built-in functions that do a lot of the plots that you're looking for you. So when you try and do box plots, it will shape them, it'll add the outliers all in one, and it'll literally just be in one line of code that you'll be able to do a lot of these visualizations. So this is another library. It's also in Python, and you can use it to make various different plots, one of which we'll show you. So I'll show you the real power of it right now. So looking at that same 4 sets of data, and since it's so famous, they have a data set. This is the data set plotted in one line. This is actually one line of Python, just a long line. These two just make the visualization a lot neater. So it just makes it into a square and adds the color palette and everything else. But these are our data sets, and later on we'll learn linear regression. And what we'll also see is that the linear regression on these 4 data sets are identical as well. So if you were to use what you learn in like the next 2 lectures on a data set blindly, you'll say, hey, I built this linear model and I'm getting decent results, but really it could be that your model is incorrect because of one single outlier. It could be because of like actual pure noise in your data, or it could be that your model is not even linear and you fit a linear model to it. And the other one is that actually all of the X values are the same. There's just one outlier, yet you can still fit a linear model using statistics. So it's very dangerous to just build models right off the bat. You really need to visualize it. And the power of the library is it did all of this in one line. The next thing we're going to talk about is the iris data set. It's the data set that I talked about. And do the similar visualizations that we saw in Weka in Python using Seaborn. And the reason I love Weka is that you automatically get all those histograms and you get those visual plots. In Python, you have to write code to be able to do that. So sometimes I'll open up a data set in Weka, take a look at it, understand the data better, and then move to Python and then write code. The reason that Python's good is because, as I said, if you write the notebook, it's reproducible. You can go back to your notebook and everything's still there. In Weka, you have to redo everything, click all the buttons again, and sometimes you can do things incorrectly, and it's not highly recommended. So the iris data set, reading it's the same way. So the data set, I have the link to it above, you can download. Here we print the same data frame. So if we just want to see what the data frame looks like. So to make comments in Python, if you don't want code to run, you just put a number sign or a hash in front of it, and it will remove, that's the code to run the thing down here. So if I remove that, I'm just going to print the first 5. I can actually print all of them, the whole data set. And if you remove the print function, and this only works if the object is the last line, it will actually print the object. And if the object is very large, you can actually scroll right within IPython Notebook. So it's pretty good that way. But for example, if I run code underneath it, the data set's not going to show up. So that's why you have to use the print function. So here I'm just going to print the summary statistics, the standard deviation, the mean, and the quartiles. And I mean, these are just numbers. Like, these give me no insights on kind of what's going on or anything like that. So it's very difficult to interpret the results. So another way you can do it, if we go back to the data set, if you notice there's going to be a class. So in this data set, we can see that there are 1, 2, 3, 4 numeric features or attributes, right? Or inputs. So that's the sepal length, which is like a property of the flower, the petal length, and the petal width. And these are all just properties of the flowers. And based off of these, it's a specific type of flower based on that family. So later when we learn classification, that's a set of problems where we take inputs and we try and predict which class the input is in. So whether it's an iris centosa, or if we go back to Weka, just because the visualization's here, whether it's each one of these types of flowers based off the data. And we're going to learn algorithms to be able to do that. But what I argue is it's very good to understand what the data looks like first before you even start the classification. So, actually I'm just going to go back to the code that I had. So next what we're going to do is we're going to learn how to draw histograms. So I want to subset the data for only this type of flower. Let's, for example, say iris centosa. If I want to do that, I'm just going to show you what the code's doing here. So if I print iris centosa, and to autocomplete, I just do IR, and then I hit tab, and then it shows you the variable names here. So I'm going to pick iris centosa. I'm going to hold Control, hit Enter, and if you notice down here, it only selected the iris centosas. If we looked at the full data set here, it's going to include all 3 types of flowers. I subset the data. And as you can see, subsetting, like slicing and dicing your data in Python, is very easy. Iris centosa is just going to be the iris data set where iris.iris. So what this means is just because our data set, the name of the family is called iris as well, because there's the name of the family is called iris. So I'm using the iris data set that I loaded, and I'm going to use the iris column. So where the iris column is equal to iris centosa, select that and save it in iris centosa. And so now if I print iris centosa, these are all of the iris centosa data. So now what we can do off of that, so that's kind of what the code there, what that line is doing. And here, to do a histogram is as simple as just looking at one of the columns. So in this example, sepal length. So I do plt.histogram, sepal length, and I get a histogram, as simple as that. So in Excel, you'd have to select the columns, you'd have to do a bunch of steps, forget about that. Just use one line of code and it's done. And then you can label your axis, always label your axis, so in here that's sepal length. And then the next thing is if you have univariate, so if you have one variable, you do a histogram. If you have 2 variables and you want to see their interaction, you do a scatter plot. So here all I did was I just plotted the sepal width and the sepal length. So it's going to be the x and then y. So it's going to have the sepal length versus the sepal width. And as you can see, this is a very manual and tedious process to do a line of code for each one. So instead, Seaborn actually has one line of code that does a pair plot for each one of these. So this is a little bit small. You can change the figure size, or you can zoom in your browser and it becomes larger. What you can do is just this one line of code, sns.pairplot with your data set, and then the hue is the color, and I want to color each one of them based off the category or the class, which is iris. So I just said the color is going to be iris, and you get each of the same plots that you get in Weka, along with the distribution. So this is sepal length versus sepal length. So it's the same variable, so it's univariate, so it just has the histogram, and you can see the histograms for each. So we are almost out of time, which is great because this is the end of kind of what I had prepared. The next actions, what you guys should do is try and install Python, try and install using the Anaconda stack. In the next tutorial, I can teach you guys how to do how to use servers. If some of you guys, it's very simple. It uses the same interface that you're used to using on your desktop. But the next actions that I think you guys should do is start looking at data. I already showed you the basic plots you can do. Look at matplotlib, look at Seaborn, and download data sets and start using them so you can get an idea for what you want to do at your projects. At the bottom of this tutorial, I included a bunch of links to all these different data sources. So this is like a full data repository. You can click each one of these links, like FedStats. You can look at the U.S. federal statistics. Here, these are some other data sets. So if you're interested in like biology, image processing, whatever your background is, I'm sure you could find an open data set that you can just download. These are other governmental data that you can download. Here's another set of like open data sets. Waterloo actually has its own data. The city has its own like database and has a lot of geo data, which is like a little bit to deal with in the beginning. But my favorite data set is actually the University of Waterloo has data sets as well. And you can actually just download them each year. And believe it or not, you can actually download professor salaries every year. So you can download them if you're using GitHub. So I'm just going to introduce GitHub in the last minute that we have. It's a site where you can upload your code. And I use Git. So what Git does is it's version control. So whenever you make changes to your code, you can save it on the server. And that way, if ever you want to revert back to your previous version, you can. So I'll introduce Git at a later time. I just wanted to introduce this interface called GitHub, and you can share your code online. So the course notes that we have for this site, I can show you right here. If we go to my repository, actually, if we go to, the repository is here. So the course notes is actually open sourced here. So actually each of the posts and each of the lecture notes that we have is completely open. So if you see any errors or anything else, you can actually submit an issue, like a new issue, and you can let me know. And you can also view data sets. So all the data sets that I present in class is on github.com/data science guide. And then you can go to the data sets and you can download them all here as well. So these are the data sets that I'll be using in the tutorials. But these are the open data sets, and you can actually view the salaries of all the staff at the University of Waterloo who make over $100,000. You can view it. It's public data, and you can do anything you want with it. So that's, for example, salaries, and there are a ton of other data sets. So so what I would recommend hopefully by next tutorial, try Weka. Weka is really easy to use. Try and get Python working. And then just start making basic visualizations. Go to the matplotlib site and look at the gallery, and then literally just first copy paste the code, and then next try and change the code to do what you guys want to do. So that's all I had prepared for today. Hopefully you guys understood the power of visualization, why summary statistics aren't enough, and hopefully I showed you enough that you can get an idea on how to get started. Thanks.